Hello everyone. In this video I'm going to talk about linear and quadratic probing in open addressing scheme. So let me get to the example. So as you can see, we have a hash table and the total number of slots here is 307. Okay, and we have a key value pair and we have a hash function that uses modulo division method, and it generates a hash value taking key as the input. Okay, so here you can see that this particular key value produces a hash value of 1, which means the address is 1. Therefore I insert this value, key value pair here. The second employee, the hash function produces hash value of 2. So this slot is available. So I'm going to record that key value pair over there. For the third employee, the hash value is 3. So right here, and this is also available. So I'm going to insert it here. Now here is a problem because this new key value pair for the fourth employee is generating a hash value of 2. But 2 is already, slot 2 is already occupied. So now we say that collision has occurred, okay, because two different key values, the one that is here as well as this key value, is producing the same address. So, but I can only store one key value pair here. So now I need to find a new slot for this key value pair. So that is nothing but collision resolution. So one of the methods of collision resolution is linear probe. So I think I talked in the previous video about we send a probe. Okay, so in linear probing, we add a constant value to the hash value. So here our hash value was 2. So we had collision. So we'll send a probe. So a probe basically checks a particular row in the hash table. So this probe is getting an address of 3. We just add a constant value to 2 in linear probing. So in this case, I'm just adding 1 as a constant value. So the probe will now go to the address 3 to see if that is available. Remember, this is the first probe. Okay, but you see that this is already occupied by some other key value pair. So this probe has failed. So now I'm going to send a second probe. I'm going to add the same constant, which is 1. So here there was collision. So I added 1 to that to generate a new address, okay, which is 4. And I'm going to send the probe, my second probe, to that particular slot, okay, to see if that is available. So now we see that the probe has returned true, has succeeded, because this slot is empty. So now I can insert this key value pair here, and that resolves the collision. Okay. So linear probing is simple to implement, but the only problem with the linear probing is it produces what is known as primary clustering. So all the collision key value pairs are grouped near to one another. So this creates a problem as more and more key value pairs collide. Okay, so we have another method called quadratic probing. So if you remember linear probing, we added a constant value whenever collision has occurred. Okay, so in this case, in case of quadratic probing, we add the square of the probe number being sent to our current address where collision has occurred. So the first probe will contain the address of the address where collision occurred plus 1 square. So this 1 denotes probe 1. So if this probe 1 returns false, that means this new value address is occupied, then we send the second probe. And to that second probe, we give the address as the value of where the first collision occurred plus probe square. So second probe means 2 square. So in this way, they are not close to one another, and we keep sending the probes until we find an empty slot. Okay, so here is an example. I have this employee who's, again, I'm using modulo division, so its hash value is 3. Okay, and here we are talking about quadratic probing. Okay, so I put it here. Okay, now as in previous case, collision has occurred. Okay, so now I'm going to send probe 1. Okay, so 2 plus 1 square, that would be again 3. All right, but that is occupied just like the previous example. So now I'm going to send a second probe. So when I send the second probe, I'm going to add 3 plus 2 square, where the probe number is 2. So here the first collision occurred, second collision occurred. Then I'm going to use this value and add to that the probe square, which is 3 plus 2 square. Okay, so that will return, the probe will check the address having 7 as the hash value. So now this is available. All right, and therefore we insert this new key value pair here. Okay, all right, so the address where collision occurred plus the probe number square, and then this returned false because it is occupied. Therefore a second probe was sent with where the collision occurred plus the probe number square, which is the second probe. So that returned true because this slot was available. Okay, thank you.